Welcome everyone. Today I will discuss about sterilization. Now, what is sterilization? Sterilization is the process of killing all microbial agents including bacterial spore. Now come to classification of sterilization. Sterilization is two types. Number one, physical sterilization. Number two, chemical sterilization. Physical methods are four types: heat, radiation, filtration, and ultrasonication. Sterilization is of two types: physical sterilization and chemical sterilization. Physical methods are four types: heat, radiation, filtration, and ultrasonication. Heat again divided into two types: dry heat and moist heat. Moist heat again classified into three types: below 100 degree, at 100 degree, and above 100 degree centigrade. Heat two types: dry heat and moist heat. Moist heat again three types: less than 100 degree centigrade temperature, at 100 degree centigrade temperature, and above 100 degree centigrade temperature. Now come to dry heating method. Example of dry heats are hot air oven, flaming, red heat, and incineration. Hot air oven is the most common method of dry heat, and then red heat is another method. Red heat means the instrument is held on a flame until it becomes fully red. By this method, we can sterilize inoculating wire loop. And incineration is the process where the infected materials are burnt into ashes. Infected materials like infected gauze piece and other specimens are burnt into ashes. Then come to functioning temperature of hot air oven is 160 to 100. Duration is 1 to 2 hours. This hot air oven acts by denaturation of protein of the microbes and also cause oxidative damage, and due to heat there will be increased concentration of the electrolytes within the organism, and ultimate result will be destruction of that organism. By hot air oven we mainly sterilize glasswares. Glasswares like test tube, petri dish, beaker, glass pipette, etc. Number two, oil and powder like substances are also sterilized by hot air oven. Powder like agents and oil like glycerin. grease are sterilized by hot air oven. Then come to moist heat method of sterilization. Below 100 degree centigrade temperature, the methods are pasteurization, water bath, vaccine bath. At 100 degree centigrade temperature, boiling, steaming and Tindalization, and above 100 degree centigrade temperature, autoclave. So moist heat three types: less than 100 degree centigrade temperature. Example are pasteurization, water bath, vaccine bath. At 100 degree centigrade temperature, boiling, steaming, Tindalization and inspicitor. And above 100 degree centigrade temperature, it is autoclave. From here, we will discuss pasteurization, Tindalization and autoclave in details. First come to autoclave. Functioning temperature of autoclave is 121 degree Celsius and pressure, it is a closed system and pressure will be 15 pounds per inch square and duration is 15 minutes. This autoclave is a closed system. Autoclave is a closed system. This autoclave is a closed system. Here steam under pressure is used and steam under pressure has more penetrating power, and when this steam comes in contact with the loaded materials, they condensed into water and produce a large amount of latent heat. This latent heat also increases efficacy of sterilization, that means efficacy of autoclave, and under pressure the boiling point of water also increased. And this autoclave work by this mechanism, and the materials we can sterilize here are blunt surgical instruments, number 2 dressings like gown, apron, surgical gauze piece. These dressing are draping sheet. These are sterilized by autoclave. And number 3, agar based culture media. Agar based culture media like blood agar media, McConaughey agar media, chocolate agar media. So these materials are sterilized by autoclave. And autoclave is that means moist heat is better than dry heat, because here time required is less and steam under pressure destroy the microorganism just within 15 minutes, and steam under pressure has more penetrating power, and here a latent heat is produced. This latent heat also increases the efficacy of sterilization. Then come to pasteurization. Pasteurization is the process by which milk is heated up to such a temperature to destroy the microorganisms within milk without alteration of color, flavor, composition and nutritive value. Pasteurization is the process in which milk is heated up to such a temperature to kill microorganisms within milk without alteration of color, flavor, composition and nutritive value. This is called pasteurization. Pasteurization is three types. Number one, holding method. Number two, flash method. Number three, ultra high temperature method. In holding method, milk is heated at 63 degree centigrade temperature for 30 minutes and then rapidly cooled to 5 degree centigrade temperature. In flash method, milk is heated at 72 degree centigrade temperature for 15 seconds and again cooled rapidly. Then comes to ultra high temperature method. Here milk is heated at 130 degree centigrade temperature for 2 to 3 seconds. These are the methods of pasteurization, and the organisms are killed are Mycobacterium bovis, Salmonella, Shigella, Brucella, E. coli, Staphylococcus aureus. So in pasteurization, these organisms are killed: Mycobacterium bovis, Salmonella, Shigella, Brucella, E. coli and Staphylococcus aureus. Then come to Tindalization. Tindalization is a process of sterilization by using intermittent heat. At 100 degrees Celsius temperature for 30 minutes for 3 consecutive days. Tindalization is a process of sterilization using intermittent heat at 100 degrees centigrade for 30 minutes for 3 consecutive days. That means Tindalization is a time consuming procedure and it requires 3 days. It requires 3 days. First, the materials are heated at 100 degree centigrade temperature for 30 minutes on first day. For this heating, all the vegetative bacteria destroyed, but spore remains. After heating at 100 degree centigrade temperature for 30 minutes, all the vegetative bacteria destroyed, but spore remains. Then these spores are incubated at 37 degree centigrade temperature for 24 hours. After incubation, this spore germinates to vegetative bacteria. After germination to vegetative bacteria, on second day, again heated at 100 degree centigrade temperature for 30 minutes. Then these vegetative bacteria again destroyed, but some spore remains. And after second day heating, then it is again incubated at 37 degree centigrade temperature for 24 hours. And on third day, all the remaining spores are germinated to vegetative bacteria. And on third day, third time heated at 100 degree centigrade temperature for 30 minutes. And after third day, the materials, the instruments are completely sterilized. By Tindalization, we sterilize egg serum containing media, egg serum, gelatin and sugar containing culture media like Loeffler's serum slope, Lowenstein Jensen media. Loeffler's serum slope, this media contains serum, and Lowenstein Jensen media is enriched media used for culture of Mycobacterium tuberculosis. Here egg is used. So these media are sterilized by Tindalization. So till now we have finished dry heating method, moist heating method, and now come to radiation. Common radiations are beta radiation, gamma radiation, UV ray, infrared ray. Here commonly used method is gamma radiation. This gamma radiation act by producing free radicals. As this gamma radiation is ionizing radiation, it produces free radicals. These free radicals destroy the DNA molecule, break the DNA molecule and ultimately kill the organism. By gamma radiation we sterilize rubber and plastic materials, which are heat sensitive, like disposable syringe, surgical gloves, endoscopes, etc. And these materials can be also sterilized by a chemical method called ethylene oxide. So the materials which can be sterilized by gamma radiation can also be sterilized by ethylene oxide. Now come to filtration. Common filters used are HEPA filter, Chamberlain filter, Sheets filter, Barkfeld filter. HEPA means high efficacy particulate air filter. High efficacy particulate air filter. The pore size of this filter is 0.3 micron. 0.3 micron. In case of antibiotic solution and IV fluid, we sterilize by this filtration method. Then at last come to chemical sterilization. The chemical used for sterilizations are ethylene oxide, formaldehyde, glutaraldehyde, alcohol, phenol, Dettol, Savlon, etc. This ethylene oxide is used for sterilization of heat sensitive rubber and plastic materials. I have already mentioned along with gamma radiation. Heat sensitive materials like Foley's catheter, disposable syringe, then surgical gloves, etc. Now come to spore killing procedures. Among all these procedures, which methods kill spore? Among physical method, there is hot air oven, which is dry heat method, autoclave, which is moist heat method, gamma radiation, which is a radiation method, Tindalization, which is moist heat method. And among chemical method, ethylene oxide, formaldehyde, glutaraldehyde. These methods are sporicidal methods, that means they destroy bacterial spore. I have already mentioned that we sterilized blunt surgical instruments by autoclave. Blunt surgical instruments by autoclave. So what will be in case of sharp instruments? Sharp instruments are sterilized by 5% Lysol or cresol. 5% Lysol or cresol. In chemical sterilization, I have forgotten to give this example of Lysol or cresol. We use 5% for sterilization of sharp instruments like BP blade, fine scissor, etc. Now, disinfection. Disinfection is the process of killing almost all but not all microorganisms. That means it will not absolutely kill all the microorganisms. Some spore may remain. So examples are formaldehyde, glutaraldehyde, phenol, Lysol, cresol, Dettol, Savlon, bleaching powder, hypochlorite, etc. And there are 3 levels of disinfection. Number 1, high level disinfection. Number 2, intermediate level disinfections. Number 3, low level disinfection. In high level disinfection, it will destroy all the vegetative microorganisms and may also destroy bacterial spore. For example, formaldehyde, 8% glutaraldehyde, etc. And in intermediate level disinfection, it will destroy all the vegetative microorganism except bacterial spore. Example, 2% glutaraldehyde. 2% glutaraldehyde. When 8%, it will be high level disinfectant. When 8% it will be high level disinfectant. When 2% it will be intermediate level disinfectant. Then low level disinfectant. This will destroy only some vegetative bacteria and envelope virus. Don't destroy mycobacteria and don't destroy bacterial spore. Example, Savlon, Dettol. So disinfection is the process of killing almost all but not all microorganisms on non-living surface. Then come to antiseptic. Antiseptics are mild chemicals which are non-toxic, non-irritant, used at low concentration on living surface to destroy microorganism or inhibit growth of microorganisms. So antiseptics are the mild chemicals which are non-toxic, non-irritant, used at low concentration on living surface to inhibit growth or to destroy microorganisms. So, difference between antiseptics and disinfectants is important. Difference between disinfectants and antiseptic. Antiseptics are mild chemical, disinfectants are strong chemical. Antiseptics are non-irritant, disinfectants are irritant. Antiseptics are used at low concentration, disinfectants are used at high concentration. Antiseptics are used on living surface, disinfectants are used on non-living surface or inanimate surface. Antiseptics are not harmful to human tissue, but disinfectants are irritants, so they are injurious to human tissue. An example of antiseptics are Savlon, Dettol. An example of disinfectants are formaldehyde, glutaraldehyde, etc. That's all about sterilization and disinfection. Hope it will be helpful for you. So now I am writing some instruments. You try to remember the method of sterilization. Petri dish, inoculating wire loop, agar based media, operation theater, egg containing media, glycerin, Foley's catheter, disposable syringe, tongue depressor, milk, fine scissor. So try to solve these problems. If any confusion, please make discussion with your friends. Thank you.